Hello guys, welcome to Ramta Solutions. Welcome to your second last lesson on differentiation calculus. So today in our application examples, we're looking at an example that says determine the area of the largest possible rectangle if y equals 18 minus 2x squared. As you can see, this graph here is a parabola which is frowning, hence it is negative 2x squared. So we need to define the area of the largest possible rectangle under this curve. All right? So what we are going to do is to understand that we can find this point here. We can also find this point here. We know the x value here because, as we can see, this is the axis of symmetry. Let me use a red color. This is the axis of symmetry, and the distance from the x-axis to this point here, the y-intercept, is 18. As you can see, y-intercept is 18. So distance from O to D is similar to distance from O to C. Why? Because this line is the axis of symmetry. So if this is x, this must be minus x. Okay, so first thing first, let's find y at point A. So I will say, remember we said y equals 18 minus 2x squared, right? This means A has coordinates x, and where there's x here, we put x. So this means A has coordinates y equals 8 minus 2x squared. And then let's go look at B. When we look at B, its x value will be negative x. Okay, it'll be negative x. So when we substitute this, it'll still be y equals 18 minus 2 into negative x all square. This is still 18 minus 2x squared. So y value of point B is still 18 minus 2x squared. Okay? Now, in the same way, we can find the coordinates of point C and point D. As you can see, these are x-intercepts and they are on the same line. So point C will be negative x and 0, while point D will be x and 0. Let's go back and confirm. Yes, they are. Okay, so we are looking for the area of the largest possible rectangle. Right? We are looking for the area of the largest possible rectangle. Right? So what we know that this is a rectangle. So basically we know that for a rectangle, first we need to find the distance BC and the distance AB. Okay, let's find BC. BC will basically be, let's do that. BC, remember, is equal to AD. Okay, it is equal to AD. It is equal to 18 minus 2x squared minus 0. Right? 18 minus 2x squared minus 0. This is simply 18 minus 2x squared. I did this deliberately because I'm saying minus 0 because they are lying on the same line. So distance between the 2 points that are on the same line, vertically or horizontally, is basically final minus initial. Okay? So BC is equal to AD. It is 18 minus 2x squared. Now, let's then look at AB, which is also equal to DC. AB, which is also equal to DC, is equal to, let's see, the difference here is the x values, so it will be x minus x. So it will be x minus x, which is, what is it? It is 2x. Okay, it is 2x. Therefore, area of the rectangle, as we know, area is basically length times breadth. Okay, area is basically length times breadth, so it's BC times AB. All right, it's BC times AB. In fact, let me just draw it here. A, B, C, D. So area of the rectangle is AB, length times breadth. All right? Okay. So what is BC? We said it is 18 minus 2x squared. What is AB? We said it is 2x. So further simplification, this is 36x minus 4x cubed, right? 36x minus 4x cubed. This is A. As you can see, A is varying with x only. So we need to find, whether you say A prime, you can say A prime, or you can say dA, dx, it doesn't matter. Okay, so let's get into it. I will say dA, dx. So dA, dx, now we are optimizing. dA, dx, this is to find the largest. dA, dx equals, as you can see, 36. Yes, it's 36. It's 36 minus 12x squared. Minus 12x squared. Is it? Yes, it's 12x squared. Now that we have differentiated this, we need to equate the derivative to 0, meaning 0 equals 36 minus 12x squared. All right? Okay. So what we have 12x squared equals 36. X equals 12x squared equals, I think, 3. So x equals plus minus root 3. But because these are values of an area, we can't really say an area can be negative, right? So we will therefore say x equals plus root 3, positive root 3. Okay? A equals positive root 3. Now, we did not answer the question. The question was saying we must find the values of x which make the the values of we need to define the largest area which makes the rectangle to be greater. So we found the value of x that will make the rectangle to be greater under this curve. So now let's find the area of this rectangle that can be the greatest. So we will say now, substituting what we got into this. So what we got was A equals 36x minus 4x squared, right? Minus 4x squared, x cubed, sorry, 4x cubed. So this is 36 into, okay, take your calculator and find this. 36 into minus 4 into root 3 cube. So that is 24. That is 24 root 3, which is basically 41,57 unit squared. Okay, because it's an area, I will say it's unit squared. All right, it's 41,57 unit squared. Okay, so this is how you attempt, or how you attempt this question. Okay, this is how you attempt this question. I hope I didn't leave anyone behind. All right, so this is it, guys, and bye bye.